Hi everyone, we're glad you could join us on this webinar about adaptive machine learning for enterprise financial crime. Thank you to our partner, Level 5, for suggesting our insights into this very interesting topic. My name is Neldy, and I am the Fraud Product Marketing Manager here at Featurespace. And it's my pleasure to introduce Dave Excell, a founder here at Featurespace, also the speaker today, who'll be sharing his insights. I'll present questions you have to Dave at the end of this webinar, but should we run out of time to answer all your questions, please submit them to the email below. Over to you, Dave.
Thank you, Nelly, and I'm pleased to be here today to be able to speak about adaptive machine learning and how that can be adopted into enterprise financial crime solutions, and for you as professionals, what you need to know when you're looking at buying solutions and then implementing those solutions into your environment. But to start off, I just wanted to provide a quick introduction to Featurespace and who we are and the types of problems that we solve. So I founded Featurespace in 2008 when I was studying at the University of Cambridge. And one of the things that I was really fascinated with was how we could teach computers to understand the behavior of people. And so while working with my PhD supervisor, Professor Bill Fitzgerald, we came up with a concept that we called adaptive behavioral analytics. So this was a new approach in terms of being able to apply statistical algorithms, or what we talked to today about machine learning, and how we can make that adaptive to understanding the behavior of people as they interact with different products and services. And that really led us to a brand new way of being able to fight fraud and financial crime. A lot of traditional systems really focus on understanding the bad behavior that's taken place within an existing customer set. Instead, when we were working with our initial customers, we always saw that fraud and financial crime continued to evolve and change. So it was a continual cat and mouse game where either new strategies or new models were being developed to capture the new types of fraud that was being created and implemented by the cyber criminals or the financial criminals. So instead, we tried a very different approach, we said, well, let's focus on modeling and understanding what a good customer looks like, and how can we describe their behavior in a way in which the computer can understand and model it. And then from that baseline of good, use that to identify anomalies and changes to then help us identify new types of fraud attacks or new types of criminal activities, so that the system continues to be up to date without needing to be refreshed and updated. And that's one of the key advantages that we have in the technology that we've built at Featurespace, is the system continues to be adaptive and evolves with how your customers interact as you take new products to market, as you change how those products work. Is our system continues to evolve with that, as well as evolving with the financial criminals and their behavior as they try to perpetrate the defenses that you put in place. So today we work with customers right around the world, including 5 of the leading banks in the United Kingdom, as well as financial institutions in the United States and also within the Asia Pacific region as well. So we really have a global presence, which helps us to work towards our mission of being able to risk score every transaction in the world. Today, we're protecting millions of customers. So one of the recent stats was around 500 million consumers are being protected by the ARIC Risk Hub, which is the way in which we deliver our analytics into our customers' environments. So to talk a little bit around how fraud and financial crime is prevented and identified today, we often talk about 3 different techniques that are applied to be able to do that. The first is around rules-based fraud prevention, which is what a majority of systems are today. The second is then around traditional machine learning, which is essentially an optimization of those rule systems, where they're looking at sort of more discrete ways of describing or understanding the activity that's taken place. And then what we've developed at Featurespace with our adaptive behavioral analytics. So if we look at rules-based systems, these are usually definitions or statements around a particular activity. So a very simple example could be around a transaction amount, where we're looking at how much a customer is spending, and we're using that to determine whether or not we want to allow that transaction to take place or not. And as things evolve, is we develop more and more complex strategies to be able to capture that behavior. But one of the things that we often see in practice is that the cyber criminal or the financial criminals are able to identify when their transactions are being stopped. They're able to then reverse engineer the rules that are being put in place, and then they change their behavior to be able to avoid being captured or blocked by that particular rule. So then what happens within in your environments is that you then need to update those rules, you need to modify those rules, and you need to continue to evolve those rules. And that has a high operational cost in that you need to keep maintaining those fraud strategies. And it's difficult to manage. Those rules then start to capture genuine customer behavior, which then impacts your customer experience and also your ability to drive revenue through your products and services that you're offering to customers. So although it's a simple and very descriptive way of being able to identify and stop financial crime, it's a relatively blunt tool to be able to stop the activity and to capture the true sophistication of what financial criminals are able to do today. When we then move forward into looking at machine learning, that's essentially taking away some of the human element of rule creation and then giving that to the algorithms to be able to optimize what's taking place. And in the market, we see both traditional machine learning solutions and then also what we've developed at Featurespace to try to work around some of the shortcomings that apply in practice when you're looking to use those particular solutions. So when we're looking at machine learning systems, is they're often then deployed into a production environment and they take a period of time to then be fully effective. But then as the financial criminals start to change their behavior and adapt and evolve to what they're doing, is those models then need to be updated and retuned. So taking historic data out of those production systems, matching that with the fraudulent or the criminal behavior that's taken place, and then retuning and optimizing those models around that new type of behavior, and then a manual effort of them being able to deploy and upgrade those systems in your production environment. So to overcome those shortcomings, what we've developed at Featurespace is the ability for those models to be truly adaptive and to continue to learn within the environment. So they're learning based on how your customers are using your products and services. We're capturing data about the transactions they're making, how they're logging into the service, how they're signing up to the service. And all of that continues to refine those profiles of understanding who those individual customers are, what good looks like, and then using that baseline of good to be able to identify anomalies and make changes based on those adaptively within the system. So what this then is, it gives you the advantage of you're able to react very quickly to new types of fraud or new types of crime that the system hasn't observed before because they're identified as anomalies from those changes. And it makes sure we're able to optimize the experience for your customers so they're not being stopped by those by fraud systems that are preventing those transactions from taking place when it is genuine customer activity, which is occurring within your environments. And this is something that we've had very great experience with working with our customers and really being able to capture more fraud and crime and being able to unlock additional revenue from your good customers. So moving forward, so what is the process that we would typically go through when we're looking to implement one of these solutions? So one of the core things at Featurespace is we really want to understand your business. We want to understand your customers and build a solution which works extremely well in your particular environment. So all of our models are built from essentially using historic data to start with where that's available. We can also work in environments where there is no historic data, and then over time start to incorporate that data into our machine learning model. So once we've got access to that historic data, we then start a process of exploring and understanding that data that you have. That's to map that data back to your business processes to understand how that data is being generated, what the true meaning of that data is, and then how we can then marry that back to either the fraud or the financial crime cases that we can see and then use within the models to be able to learn from. And this is something that we work together with you and with your customers, is to make sure that the quality of data which is going into the system is extremely high so that we can make sure that we've got good value detection at the end of the process. So from the exploration of the data is then we go through a process which is called feature engineering. And features is one of those elements which is part of the art of data science in being able to look at how do we present the data in a way that the algorithms can then understand the behavior of your customers and then be robust to changes that we see within that data as your customers change, as you add new products and services to your customers. And also part of where the name of Featurespace comes from is that process of being able to identify and capture the appropriate features for that use case. So at Featurespaces, we have a number of really unique features that enable us to capture those behaviors that make us very efficient in being able to highly optimize our detection of fraud and financial crime. So once we've gone through the process of mapping those features into your data and truly understanding the intricacies of your data, is we then turn the solution over to the algorithms and the machine to be able to optimize the detection, really uncover the patterns that are taking place, and then finalize and complete that model. And so at the end of this process is we have a model that's been built around your data sources, which is truly optimized to be able to be reactive to new types of fraud, being able to understand the specific use cases of that data within your environment, and also to be able to understand the types of fraud that you've experienced and be ready to identify new types of fraud as they take place. So once that model has been built, is that we're then able to deploy that within our ARIC Risk Hub. And this is then the software which is built to be bulletproof and sort of serve as a mission critical component of your infrastructure to be part of your transaction flow, to be able to understand those transactions, make decisions in real time if necessary, to either decline a transaction or to request further authentication for that transaction. But also, more importantly, being able to constantly update and refresh. We're able to evolve those models every time that we see a customer make a transaction, every time we see them interact from a new device, every time we see them log in. All of that data is constantly fed back into the solution so that we can optimize those scores and make sure we're making the most efficient decisions that we can within the platform. And this is something that's done without any manual intervention. It's something that's completely automated within the platform with appropriate levels and controls that you have in place to understand the boundaries in which that is moving. So one of the other really important things when deploying these systems is to make sure that there is an appropriate model risk management approach, is to understand that as the system is evolving and the decisions that are being made are done using a correct understanding of what your goals are as a financial institution. So what is the right types of behavior that which should be detected, and how are those modeled and identified through the data, understanding the quality and the health of that data and making sure that data remains consistent right through the initial process of deploying and delivering the model, but also once that model is deployed within production, and then making sure that model is aligned with key industry trends. So as we start to see fraud evolve based on experiences in different markets, and also looking at sort of variations and volatility in customer activity, being able to make sure that the model is robust to those different changes. And then finally, it's about working with you to understand the performance of that model, where you want to operate and detect at that model in terms of the level of detection of financial crime or fraud, which is important for you in your risk strategy, and the trade-off that you then have about potential impact to genuine customers and trying to minimize that friction as much as possible. So in the process of doing this is we create a documentation to make sure that it aligns with your model governance approach to ensure that right across the organization, there is sign-off in terms of the capability and the usefulness of the model. And then this typically results in the generation of a model documentation, which is then compliant with different regulatory requirements to be able to show how the model is built, the methodology around that, and the testing that's been done around that model to ensure that it's robust to all the different types of changing. And also importantly, I guess in this day and age is also to ensure that there are no biases within the data, is that we're treating all consumers fairly, and we're making sure that the model is truly acting on identifying the financial crime and not looking to disadvantage any particular classes of people within the data set. So this is something in terms of not just creating the technology which is able to identify the fraud and financial crime, but being able to provide a complete service and being able to deliver the solution so that it runs in your production environments at real time to be able to make those decisions, but then also to be able to support your regulatory and compliance requirements to ensure that these models can then be delivered and you're confident about the output that they're going to ensure for your customers and the regulators. And it's not just about working with the models that we develop at Featurespace. We also want to work cooperatively with your own data science teams and enable them to be effective in also working to fight financial crime and fraud. So to do this, we also have the ARIC open modeling environment, which enables you to use best of class data science tools to be able to develop and build models and then deploy those within our environment. So this gives you the independence to focus on specific use cases where you think that that's important and you want your own teams to be able to focus on that. The ability to be able to mature those models and deploy them with no downtime within the production environment. And then also the ability to be able to deploy and test, to be able to run champion challenger scenarios to understand what the upside is of deploying a new model and being able to identify the trade-offs that take place. So to enable this is we support the ability for you to import models that are developed and exported through the PMML markup language and also through the H2O solution and also through TensorFlow. So both of those frameworks enable you to create artifacts through those solutions, and then those artifacts can be uploaded into the Featurespace platform and then used to score transactions, to write rules around those scores, and then to impact what you're doing on individual transactions as they flow through the platform. So this gives you the flexibility of both working with our data science team and deploying the adaptive models that we have at Featurespace, and enabling your own teams to be able to use their own specialty and expertise to focus on specific use cases that you want within our platform. So once the models are deployed, it's really important to be able to integrate this within your transaction flow. And there's various ways in which this can be done. And this is an illustrative way, in a common way in which some of our customers use our platform. So at the beginning is the system is essentially triggered by customer activity. So whether or not this is a transaction or a login or a payment which is taking place from that customer and what they're doing. From that request or that transaction coming in is that you typically call out to the ARIC Risk Hub and essentially ask for a risk request to be taken place. So this is where we're going to either score the transaction or we're going to deliver a decision, which is to decline, accept, or do some other further action on that particular transaction. But also what can be important as part of that process is to call out to a third-party data source to do additional verification. So it might be for a device ID supplier to be able to identify the trust or reputation of that particular device, to do some IP verification, maybe to understand the geography where the IP address is coming from, or further to understand email verification and understand if there's been email associated with that, if there's been fraud associated with that email address in the past. So once we've called out to that third party, we can capture that data and then incorporate that into the risk assessment that we're taking place. So we can take that information, and then there may be a process where you want to further authenticate that transaction. You may be suspicious of where the transaction is coming from. It's slightly unusual for that customer, but rather than declining it and sort of adding sort of dissatisfaction to genuine customers, is we can call out and ask for a one-time password or to provide some other information to verify that it is actually the genuine customer who's requesting for that transaction to take place. So once we have that authentication request, and that can be optional, we can then go through and use that to provide our final risk response to the payment platform and the transaction platform to either authorize or accept the payment or decline the transaction, depending on what we want to do in that particular circumstance. Further to that is that we can also then create an alert. So it may be a case where we want to have a human in the loop to be able to analyze what's happened in that particular customer scenario, especially in an AML circumstance when we're looking at financial crime. So we can coalesce all of this data together and provide a view of the complete history of what that customer has done, and providing the scores and reason codes that have been generated by the model, and also the actions that have been triggered through the result of this. So this gives us rich information to the investigator to be able to understand what's happened, and then to make a determination if the activity from the customer is truly fraudulent or requires further investigation from an AML perspective to be able to go through into the solution. The result of this alert is then fed back into the platform, which then really powers our self-learning algorithms. So this is where we're able to take the feedback, incorporate that within the models, and then in the future start to incorporate that in recalibrating our scores to ensure they continue to remain accurate. And then all of this information can then either flow back into the payment platform. So if there's a case in which we want to then block a customer or close a customer's account, that information can then be facilitated and flowed back into those platforms. And then also the data can be exported into your data lakes to enable further reporting and investigation where you want to take a deeper look into that data for ongoing analysis into the future, and have that ongoing repository of information. So now just to go on to two different use cases in terms of how our technology has been deployed and used in different areas of the financial services industry. So this was a use case that we did with a card issuing organization in the United Kingdom. And they essentially came to us where they were had a high false positive rate in terms of they were declining a large number of genuine customer transactions to be able to capture their fraud. And this was particularly strong in the card not present space. So for all of those transactions which were taking place online where the customer wasn't physically present at the point of purchase. And also in the graph over on the right is that we can see is they had a lot of volatility in terms of the number of alerts that were being generated on a daily basis. So this drove increasing demand into their call center as those customers had their transactions declined, which made it difficult to then staff those particular environments. So one of the objectives that they gave to us was how to provide some consistency in that line, so it was much easier to staff from an operational perspective what we're able to do. So by deploying our solution and being able to analyze this data, we had some dramatic impacts in terms of what we're able to deliver. So we're able to, firstly, significantly reduce that false positive rate. So overall on their portfolio, it was operating at a 10-to-1 false positive ratio, which meant for every one fraudulent transaction is 10 genuine customers were being declined. So we were able to reduce this by 70% down to 3-to-1, which is a dramatic change for them. And even further on the card not present side, that was running at a 23-to-1 false positive ratio, and we were able to bring that down to 6-to-1 while still capturing the same amount of fraud. But also going back to that secondary objective about trying to reduce the volatility of alerts is that we can see the white line that's introduced there. So that's where we're able to stabilize the amount of alerts that were being generated by the system. So it was much easier to organize and staff and manage that customer impact where those alerts were being generated and the customers were calling into the customer contact centers. So this was a great example of where we're able to use the solution to benefit both the customer experience, capture more fraud, and then improve the overall efficiency of the fraud operations within this card issuer's environment. So a second place where we've been able to deploy our technology is to identify financial crime in an AML setting. So this has its own intricacies compared to fraud, where we often don't have the same level of examples or the same confidence into those examples in terms of the types of activity which is deemed to be truly suspicious and results in suspicious activity reports. And there's also a lot of manual work which is done in the investigation of these alerts and the process in which they are then reviewed and escalated within an organization. So within this particular organization is they really gave us the challenge to work within their existing alerts that they were being generated and try to look at ways in which that process could be optimized and prioritized, where we could look at where were the alerts that were the most suspicious and where those should be prioritized within that data set. And we had some truly amazing results when we looked at what we were able to deliver with our technology for that particular customer. So initially what we're able to show is that we could reduce the overall alert volume by 12%. So typically a lot of AML solutions deliver like thousands or tens of thousands of alerts into operational teams. And what we did with this organization is looked in ways in which we could identify what those alerts were trying to do, make sure that they were still compliant with the different types of regulation that were required to be met by this organization, but look to bring the volume down to make sure that we were really truly identifying the right behavior that was important for this particular customer. After reducing the volume of alerts, by then prioritizing them, is that we could find that by only working within the top 5% of those alerts, is we're able to identify all the suspicious activity reports that they had previously captured by their operational team. So this gave them a tremendous advantage by being able to efficiently organize their work to focus where they should, to look at where they should really focus their activity when they're looking at the investigation of the alerts which are being generated by the system. And then finally, through the analytics, is that we're able to bring forward the time in which the suspicious activity was being alerted and identified by the system by more than a month. So this enabled them to be more on top of the activity of their customers and be more proactive in reporting this information to the regulator, rather than having it run on for longer before they are able to capture and identify that information. So thank you very much for your time today. It was a pleasure to speak to you. And Neldy, were there any questions from the audience?
Yes, so we have quite a few questions, Dave. Not sure we'll get through them all, but some interesting ones. The first one being, you talked about fraud data being not normal. So why does that matter to a machine learning model?
So that's really important for a machine learning model, because what we're trying to do with machine learning is identify the different types of patterns that exist within the data sets. And so what we're looking at is building solutions that enable those machine learning algorithms to identify both the patterns of good behavior and then bad behavior. And that really then helps it to differentiate and score that activity differently. So we're able to use those differences between that data to be able to identify the fraud that's taking place.
Right, let's move on to the next question. What if you don't have enough data to train your own model?
Well, surprisingly, most organizations, even though they don't have a lot of data, actually have enough for us to be able to deploy and build our models. So we don't need a huge amount of data to be effective in using our solution. And if you're in an environment where maybe you're launching a new product or service and you don't have any data for that service, is we can deploy our solution and use rules to start with. And then as we collect more data into the solution, is we can use that data to then deploy a model and then protect you, and so that you're ready as that data starts to grow and as your customer base grows.
Wonderful, right. So we have another question. Are you able to build models and rules around our data?
Yes, definitely. So that's really one of the things that we don't offer. So we don't have a consortium model which is built across an aggregate of multiple customers. Is we really want to work with your data to give you the best experience possible. All customers have different products and services that they add to their consumers. They have different ways in which that data is captured. So we really want to optimize the data that you have in your environments to make sure that you get the best product that we can provide to you.
And the next question, what can you do to identify or detect a new fraud pattern not in the historical data?
So that's one of the great advantages of the approach that we took when we created Featurespace right at the beginning, is rather than building a system which is reliant on identifying the past bad activity, is we build a solution which is focusing on what good customer behavior looks like. So if we have a very good model of how your customers interact in a positive way, as we start to see anomalies and changes from that good activity, that helps us very quickly react to new types of fraud and financial crime and highlight those through the system, so that you can proactively investigate that, truly determine that it is fraudulent behavior and stop that from taking place.
I think we've just about run out of time. So it would be great if, like I suggested at the start, if you have any questions for Dave or for the Featurespace team, if you could email us to the email address below, and then we will respond to get the answers for you. Thank you, everybody.
All right, thank you, Nelly, and thank you for everyone for listening.